Let's envision what we can do at the end of this course. You should be able to launch a Geant4 program from the command line, carry on some simulation tasks in an interactive session. You should also be able to launch a Geant4 program in the batch mode so that you can simulate thousands of events in the blink of eyes. Your simulation results can be saved in different files and formats. You would understand various physics processes attached to different particles. You can shoot various particles in different energy and angular distributions to a detector defined in a text file and visualize it in 3D. In this particular example, we simulate the response of a high-purity germanium detector in a vacuum chamber to the gamma rays coming out of a radioactive source placed near the chamber. You can turn off and on the visualization of individual components of the simulated detector system. You can walk through individual events and examine them in different angles and in great detail. Statistical analysis of the simulation results can be done using data saved in various formats, including root, commonly used by high-energy physicists. Data can be saved in arrays with variable sizes. You can draw the XY distribution of the interacting points of gamma rays in our detector system. You can see interacting points in the wall of our vacuum chamber and the germanium detector. You can assign a 90 number to different components of your detector system and use it to visualize the distributions only in that component. The density distribution of the interacting points can also be color-coded for better visualization and understanding. We can see clearly there is a hot spot close to the place where the radioactive source is placed. We can also draw the energy distribution recorded in our germanium detector in linear and log scale. You should be able to identify characteristic structures in the spectrum, such as the full gamma ray absorption peak, the single escape peak, double escape peak, Compton edge, Compton shoulder, and multiple Compton scattering events.